and good morning, Dr. Jong. I am Asri Nor Hafiz bin Ahmad Shah with the matrix number of CE230158. I'll be solving question 1 for this group project. Question 1 is proof dy dx equals to 6x square y plus x cube over negative 2x cube with the initial condition y in the bracket of 1 equals to 0, and the answer will be 8x cube y plus x with the power of 4 equals to 1. So this is my manual calculation. This for A, I'll be doing with linear equation, and this is my manual calculation. And B is homogeneous equation, and this is my manual calculation for homogeneous equation. And both of these method, linear equation and homogeneous equation, I have the same answer with this. Same goes with the homogeneous equation. I'll be showing my MATLAB, my simulation. First, for the linear equation. Step 1, I rewrite in linear form, and then I find the px and qx. This is the original equation. And I write the linear equation equals to this equation. And then given linear equation equals to 6x square y plus 6 plus x cube over negative 2x cube. And given coefficient px equals to 3 over x and qx equals to negative 0.5. Step 2 is find integrating factor I equals to e px dx. Integrating factor for px. And I write the display, the integrating factor I is equals to x cube. Step 3 is use formula y I equals to qx I dx. I'm using this formula to get new equation. And the new equation is x cube x with the power of 3y equals to negative x with the power of 3 over 2. To calculate the integration of qxi dx, the formula equation is y integrating factor p equals to qx integrating factor p plus c. So the formula equation equals to x cube x with the power of 3y equals to negative x with the power of 4 over 8 plus c. And rearrange the equation, and I'll get c equals to x with the power of 4 plus 8y x cube. Step 4, apply the initial condition where y in the bracket of 1 equals to 0 into the equation. So the final answer is x with the power of 4 plus 8yx cube equals to 1. So it is proven that the linear equation is the same with the manual calculation. For the homogeneous equation, this is my coding for the MATLAB, and I get y equals to 1 over 8x cubed minus x over 8. After we rearrange the answer, I'll get the same answer for this homogeneous equation, meaning that the homogeneous equation and linear equation have the same answer for both simulation and manual calculation. That's all from me. Thank you, Doctor.
Good morning to Dr. Zhong Xialing and everyone. My name is Wu Ming Huang, and I'm here to present about the project ODE from Group 1, Section 5. And in our group, we have four members, which is Aslino Hafiz bin Ahmad Shah, Nurul Akwa Nabila binti Muhammad Fadzil, Nor Dina Aisha binti Rosidi, and Wu Ming Huang, which is me. And for me, I need to explain about the project question of question 2, which is given a second order ODE, d square y over dx square equal to y plus x exponent power of x. And in this question, we need to solve three parts, which is the A, identify the complementary function yc for the corresponding homogeneous equation, and B is solve the given second order ODE by using the undetermined coefficient method, and the last, which is C, then show that the result will be the same as in Q2B by using the variation of parameter method.
Alright, now I will explain about the calculation of question 2. And we know that the question 2 is the question of the question 2 is d square y over dx square equal to y plus s exponential of power of x. And now I will explain about the part A, which is the identify the complementary function yc for the corresponding homogeneous equation. Okay, and now we watch for the calculation. And before we finding the homogeneous equation, we need to move the y to in front, and it will be negative y. And we know that this equation will be y double prime equal to minus y equal to 0, and it will be m squared minus 1 equal to 0. And we need to find out the value of the m1 and m2, and we can using the calculation to find out the value of this. And we find the m1 is equal to 1, m2 is equal to negative 1. And the of this condition, it will be the case 1 based on the table that we know is this. M1 not equal to M2, it will be the equation of ys equal to a exponential power of m1x plus b exponential power of m2x. So we just using this equation and sub the value of m1 and m2 into this equation, and we will get the yc is equal to a exponential power of x plus b exponential power of negative x. And this is the answer of the part A. Now we will doing the part B, which is solve the given second order ODE by using the undetermined coefficient method. And the first step we need to find we need to know the fx is equal to x exponential power of x, and we need to identify it based on the table of this, which the condition of this fx, and we know that the x is polynomial and the exponential power of x is exponent. So we know that the equation that we assumption of yp is cx plus d times e exponential power of x. And we just doing the multiplication of this equation, so we can get the cex exponential power of x plus de exponential power of x. And we know that the ce equal to c, de equal to d, so just simplify, so it will be cx exponential power of x plus d exponential power of x. And after this, we need to combine with the value of yp, the result of yp equal to y of the yc. If the yp is equal to yc, we need to multiply with x to make them be difference. So we can see the our yp is same with yc, so we need to multiply with x, and we get the yp value is cx squared exponential power of x plus dx exponential power of x. After this, we find out the yp value. We need to find out the yp prime and yp double prime value. So we just doing the differential of the yp, we can get the value of yp prime, which is 2cx exponential power of x plus cs squared exponential power of x plus d exponential power of x plus d x exponential power of x. And we're doing the second derivative of the yp prime. So we get the answer is of yp prime, the yp double prime is 2c exponential power of x plus 4c x exponential power of x plus cs squared exponential power of x and plus 2 d exponential power of x plus dx exponential power of x. After that, we find out the value of yp prime and yp double prime. We need to substitute these two values into the equation y double prime minus y equal to x exponential power of x. And finally, we will get the substitute value for this. So after we find out the value of this, we need to doing the equating coefficient, which is we get the 2c exponential power x plus 2c x exponential power x plus d exponential power of x equal to x exponential of x. And we need to doing the equation coefficient for x exponential power of x, and we get the 2c equal to 1. So we just move the 2 to behind, it will be the c equal to 1 over 2. And we need to find out the value of d. So we just using the we get the 2c plus d equal to 0. So we sub the value of the c, which is 1 over 2. So 2 times 1 over 2 will be 1 plus d equal to 0. So the value of d is negative 1. And for our equation of our yp, which is equal to for this, and we need to sub the value into the yc equation, which is y equal to a exponential power of x plus b exponential power of negative x plus 1 over 2 s squared exponential power of x minus x exponential power of x, which is this answer. And this is the answer, final answer of part B. And now I will continue for the part C, which is we need to show that the result will be the same as in Q2B by using the variation of parameter method. So we need to using the Wronskian method to do this part part C. After that, before that, we need to we do the same method with the part C, which is we get the y double prime minus y equal to x exponential of power of x, and we know the value is a equal to 1, fx is x exponential power of x, and the yc will be y1 plus y2. So we need to find out the m1 and m2 value using the calculator. We get the m1 is 1, m2 is negative 1. So finally we get the y1 is exponential of x and y2 is equal to exponential power of negative x. And after we find out the y1 and y2 value, we need to using the Wronskian method, which matrix using y1 find out the y1, y2, y1 prime and y2 prime. So we just sub the value for y1 and y2 into this matrix form. So we get the y1 is exponential power x, y2 is exponential power negative x, y1 prime is exponential power x, and y2 prime is negative exponential power of negative x. And we just doing the multiply. So we get the exponential power x multiply with negative exponential power of negative x minus exponential power of negative x times exponential power of x, and we get the final value is w equal to 2. So after this we need to find out the value of u and v. The formula of u is negative integrate y2 times multiply with y fx over aw ds plus a, and we using the value that we have and sub into this equation. So the final value of u that we find, which is s squared over 4 plus a. And for value of v, we need to using the equation integrate y1 multiply with fx over a w dx plus b. So we also sub the value that we have into this equation, and we guess this answer, but we need to using the integrate by part to make the two to find out the value of v. So after we using the integrate by part method, we find out the value of v is negative 1 over x times multiply with 2x exponent power of 2x minus exponential power of 2x plus b. After find out the value of u and v, we need to find out the y value, and the equation of y is u y1 plus v y2. So we sub the value of this into this equation. So and the final answer, we will get the y equal to a exponential power of x minus b exponential power of negative x plus exponential power of x 1 over 4 x squared minus 1 over 4 x plus 1 over 8. This is the final answer of the question 2C.
Now I will explain the part of simulation part. And now we know our question is given a second order ODE d squared y over ds squared equal to y plus x exponential power of x. And we need to we are using the simulation of MATLAB to solve this equation for the to find out the value of the Wronskian, which is the part C. So we will so SYMS with x y x and equation equal to differentiate y x and 2 will equal to y plus x times exponential x, and we need to solve this equation. We need to solve this equation and equation. Okay, and after that we press the run button. Okay, and now we will get the answer here, and this is the answer of the uh answer of the question 2, and which is the and this answer will be same as with the part C of the question 2, which is this answer. And this is the simulation part of me. Thank you.
Hi, my name is Nurul Akwan Nabila binti Muhammad Fazil. My matrix number is TE220049. Today I would like to explain the question for 3A. From the question, it's given y1 and y2 equation, and we will rearrange the equation in matrix form. After that, we will evaluate the eigenvalue for lambda 1 and lambda 2, and also the eigenvector for V1 and V2. From the manual calculation, I get the answer for lambda is 2 and negative 2. The next step is the answer for the lambda I will put in the formula to get the V1 and V2 answer. The last step is find the general solution for y1 and y2 system. I will get the y1 equation negative 5a e 2x minus be negative 2x. For the y2, I get the ae 2x plus be negative 2x. I simulate the equation by using the MATLAB. From here, we can see that I insert the two equations. After that, I declare the equation to get the answer. I put it the coding, which is ODE 1 equal to different y1, and put it the first equation. After that, ODE2 equal to different y2 and put it the second equation. And then next, I put the coding to solve the equation. After that, I will declare to solve the equation to get the same answer with the manual calculation.
Hi, my name is Nurdina Aisha binti Rosidin, and in this group, I'm solving the question 3b. Okay, for question 3b, the question is about a system of first-order differential equation where the info given in the question is y1 prime, y2 prime, the eigenvalues for the system, and the eigenvectors for the system. So for the question, we need to find the general solution yc, the particular integral yp, the general solution of the non-homogeneous system, and also the particular solution y1 and y2 when the initial conditions are given. Okay, for this question, I'm using MATLAB software. So for this software, I input the coding. Then when we run, we will get the answer on the right side of the live editor. Okay, for the first step, which is the first question in 3b, write the general solution yc for the homogeneous system. Okay, the first one is sims abx. It is to declare the symbols used in the coding. Next, info given in the question, where lambda1 and lambda2 is the eigenvalues, and v1 and v2 is the eigenvectors. Next, equation to obtain general solution yc. I put the ycx a multiply v1 exponent lambda x plus b v2 exponent lambda 2x. It will calculate based on the info given, so it will display ycx. So when we run the software, the answer is on the right side. A exponent x plus b exponent 6x, b exponent 6x over 4 minus a exponent x. Next, for the question 3b2, determine the particular integral yp for the non-homogeneous system using the undetermined coefficient method. For this question, the info given based on question to obtain C and D. X and Y is only variable. Then I include the info based on the question in a matrix form. Next, equation to solve the system through linear solve. The answer equal to linear solve xy. This is the coding need to use to calculate the question we need to find the answer. Because it is in a linear form, so I use linear solve. So C equal to answer 1, D equal to answer 2. Next, it will display answer. Then when we run the software, C equal to 1, D equal to 0. Same goes for E, F, G, and H. It uses the same step as when we want to find the C and D. When we run, the answer for E is 0, F negative 1, G negative 5, H 0. Next step, values C, D, E, F, G, and H that have obtained. C 1, D 0, E 0, F negative 1, G negative 5, H 0. Then equation to obtain YP. This is the formula for YP. And based on the equation, it will include the info given on above. So it will calculate and it will display YP. I'm using this DISP on YPX equals and also DISP YPX, because if one of these two are not in the coding, the answer will not come up. So it needs both of the display. So when we run, the answer is YPX x squared minus 5 negative x. Next, the 3B3. Obtain general solution of the non-homogeneous system. Based on the question 1 and 2, we have obtained the YC and P. So for the part 3, I rewrite the YCX and YPX. Then I put the equation to obtain Y, where the equation is Y equal to YCX plus YPX. Then it will display Y equal to. And when we run, the answer is A exponent x plus x squared plus B exponent 6x minus 5, B exponent 6x over 4, minus A exponent x minus x. And lastly, 3B4, compute the particular solution y1 and y2 given that the initial conditions are y1 0, y2 0 equal to 0. The first step in the coding is values they have obtained from YP. This is the info given that I have obtained from YP, and we need this to solve and to find the values of AB from the equation YC. X and Y in this coding I use as the variable. Then this is the info given. I use the same coding, answer equal to length of xy. Then A equal to answer 1, B equal to answer 2. We want to find the value A and B. That's why I use A equal to answer 1 and B equal to answer 2. Next, display answer A, B. When we run, A equal to 1, B equal to 4. Next, values of A and B that we have obtained, I rewrite it back. And lastly, equation to obtain Y. And then display Y. When we run, Y equal to 4 exponent 6x plus exponent x plus x squared minus 5, exponent 6x minus exponent x. So the answer we have obtained from the MATLAB software is same as the calculation. Okay, that's all from me. Thank you.